Now we'll move over to our next presenter, Dr. Iveta Eimontaite, who I sort of know a bit. We work together. Let me just introduce Iveta formally. She's a research fellow in the Industrial Psychology and Human Factors Group at Cranfield University. She specialises in cognitive psychology and neuroscience, and her expertise in human-robot interaction focuses particularly on understanding human user acceptance, attitudes, and requirements of robotic technologies, and in understanding how individual differences and cognition affect human technology interaction. So without further ado, welcome, Iveta.
Thank you very much.
You there? Okay, and I'll hand over to you. Okay.
Thank you for inviting to the session. Am I sharing the screen and does it look all right? Because somehow, okay. First of all, I must apologize if you will hear a cat meowing. She really loves to talk, so just please ignore her. So thank you very much for inviting. As Sarah mentioned, I'm a psychologist working in engineering and focusing on robots. So what does that mean is that I'm observing and investigating how actually robot users, in particular operators in manufacturing environment, how they interact with the robots, how they perceive that, and what attitudes they have towards this technology. So to start with, collaboration between users and robots is becoming more extensive, and it's actually a key for Industry 4.0. And for such collaboration to be successful, it needs to be accepted by the workforce. So the workforce needs to accept the robotics and all the new technology. And that's where the issues arise, because users, operators have either too low or too high trust. They also experience stress when they're interacting with robotics, in particular that previously robots were segregated by the barriers, by the gates, and now they are coming closer to the operators. People start to directly interact with this technology, and that causes stress because this is unfamiliar, unknown, and pretty dangerous. And also all the stress they're experiencing can affect mental workload. So users might not focus on the task, on the environment, what's happening, but because they just have either too high or too low trust, they experience the stress that and their cognitive workload increases. That means that possibility of accidents can also increase. So how can we help that? And from a variety of different studies and actually other fields, we know that effective information communication can ensure that users with new technology, they feel more empowered and in control. So whenever they know how to use the technology and what can go wrong, that actually makes them feel more in charge, and that itself decreases stress. And at the same time, it decreases anxiety and negative attitudes and increases trust towards robots. So they know what robot can and can't do. They know when things go right and how everything would look like if things would go wrong. And in turn, that actually decreases decision-making anxiety that influences mental and physical illnesses. So in general, people feel better, they are more confident in their work role, and that means that their efficiency increase, and also they are feeling more loyal and happy in their workplace. So what is is about, I guess you already guessed, it's about users and how robots and operators can interact. And I'm going to talk about several different studies and with a few different approaches. So first of all, how to investigate user needs and attitudes using free flow approach and structured approach, and also testing the efficiency. So once we know the user needs and attitudes, they are integrated in design of the new studies, how we actually can test the efficiency of the new processes or new technology, either in laboratory studies or field studies. And finally, some conclusions. So user needs and attitudes, how can we explore them? So one of pretty common approaches is free flow approach. So that means when, so in this particular study, we had a manufacturing company who were planning to introduce robots, but they were anxious that actually robots, as all previous technology, will be just put to the corner and the users, their operators won't accept or use it. So they wanted to involve involve some research and investigate how to make sure that users accept technology and they start using that. And we're using a free flow approach. That means we got 8 operators who are working directly with the technology, with the processes in the company. And we asked them to actually step out of their comfort zone and design the different signages, work cells, how they imagine that collaboration between user and technology. And such cells have 2 layers. So it has that first layer, which is the most obvious, where we ask operators to actually design and evaluate technology. But additional layer, what this approach allows, is actually allows to assess users' attitudes towards technology in question. So for example, we delivered a number of workshops, and in each workshop, participants were given pen, paper, some cutouts of robots, and they were asked to perform a variety of other tasks. One of the first tasks after they saw the robotic demo and how operator and robot collaborate, we asked them to design some signs or some information communication which should be placed around the robot that the human working with the robot would feel more confident and comfortable. And so participants, not surprisingly, they draw a variety of signs. So some of the signs indicated that stop or don't touch robot. Other signs indicated when it is safe to touch the robot. Also some robot operational properties, so robot speed and robot moving directions. So that is the first layer. The second layer, how we can assess initial attitudes from this kind of task, is actually looking where the main focus of where participants put the main focus, so how many signs they design for a particular purpose. And we can see that initially our 8 participants, 8 operators felt very anxious about the robot because 18 signs were designed to indicate stop, don't touch, don't get close to the robot, and only 5 signs were indicating that you can approach and work with the robot. By the end of the workshops, I think by the end of 3rd or 4th workshop, we asked participants actually to design a work cell. So during the workshops, we had various discussions, how they feel robots should communicate with the user, how the user should communicate with the robot, how to know when things go right, when things go wrong, just in general, that information about a technology and how user could know and feel confident in that. And the last task was actually, we gave them cutouts of the work cell and different medias of information communication, so tablets, AR glasses, projector, etc., etc., etc. And where we can see the change, that majority of the participants used either 1 or 2, maybe 3 different information communication methods, and only 1 participant used all the possible information communication methods, all the possible ways of indicating the user what robot is doing and when things are going wrong. And that just suggests that a majority of participants start feeling a little bit more at ease with the robot, with the process itself, and they needed just the main information to communicate it via one technology type. And the anxious participant, they really needed that confirmation that things are going right from a variety of different angles or different information communication methods. Another approach is a more structured approach, and that means that while in starting the study or workshop, researchers already have predefined hypotheses and variables, and they have greater control of the environment, and they can manipulate those variables. So this study was done, it was done online, and it's on a project so with an industrial partner, where they are planning to allow human and robot to collaborate on variation of pick and place tasks. So human operator and robot picks an industrial component from one shelf, and they need to carry through the factory from point A to point B and position on another shelf. So both together working. And because factory environment is not always consistent, there are some obstacles on the road, that information between robot and the operator needs to happen. And we designed a study, online study, where participants were viewing a video how operator could work with the robot, but at the same time, they saw visual communication where it indicates what robot is communicating to the participant. So we had 6 different variations of this kind of communication method, and participants view all those 6 videos, and they were asked to actually indicate what they think about each of information communication method. So we had as you saw in the previous video, we had a communication method with avatar, where the green circle indicates that human and robot are on optimal path, and when they start deviating, it turns into towards red. Also, trajectory percentage, so how much of task has been completed, and trajectory deviation indicate with the arrow indicating which direction you are deviating from the optimal trajectory. And also robot avatar, either full size or half size, the face would indicate also which direction to move. So the face would move towards right, indicating if you move towards right or towards left. And after watching each video, participants were asked, so what do they think each component of the signage meant? And they asked to clarify the clarity of each object, so avatar face and expressions, arrows, numbers, background, circle. And at the end of the experiment, participants were asked which signage they would prefer if they would need to work with this kind of technology, with this process. And 75% of participants indicated that they would just prefer background circle with trajectory percentage and trajectory deviation. Just saying that this is the most efficient, it provides all the necessary information, and it's not cluttered, it's very clear and quick way of understanding what's happening. 15% of participants indicated that they would prefer the same background, trajectory deviation, and trajectory percentage, but with avatar, because avatar, according to them, gives a little bit more personal and that collaborative feel that they are still interacting. It's just not efficiently moving from A to B, but something more is happening. So taking everything into account, although both of these studies use different approaches, the findings are pretty similar. And so what we know that user needs and requirements are from information communication. So they need to have in-depth knowledge and instant feedback. Communication and robots need to adapt to user experience. So after a certain amount of time, maybe user already knows how to communicate with the robot, what robot is going to do, so information needs to be reduced. They also expressed wish to be involved in the robot introduction and explained that the number of elements of visual information needs to be minimal, so showing only what is providing unambiguous information and does not duplicate information already presented. So once we have all this feedback, how to test that in experiment. Actually, when people interact with robots, they get physically to interact with it, and assessing does actually that information help and produce desired results. So we, in both strands of work, follow-up stage was designing a laboratory study. And with the first one, we used static graphical signage, where participants were presented signage indicating the speed of the robot, that it's safe to touch robot, how much force to touch a robot. So one condition was experimental condition with this signage. Another condition was where participants were not presented the signage. And we can see that graphical signage helps to increase accuracy on the task. So it was a simple pick and place task. It also decreases user anxiety and results in positive emotional valence during successful trials. Similarly, with dynamic graphical signage, so the strand of work with the avatar and dual arm robot indicated, so we had three conditions there. We had a control condition with no signage. We had user interface with avatar and user interface without avatar. And what we noticed is that user interface with avatar resulted in highest accuracy. So participants deviated the least from the optimal path. But also we noticed that no user interface showed highest mental workload, while the lowest mental workload, overall mental workload, was observed in interface with no avatar. So this suggests that actually when people are completing the task and they don't get that feedback, how they are completing, are they on optimal path, is everything is going all right, the mental workload increases, and that might result in more dangerous situations and some accidents happening, in particular in manufacturing environment where everything is changing quickly and dangerous situations can arise. So with testing in laboratory is great because you can control environments, you can just control your variables, but it's not the same as testing in the field. So testing in the actual factory on actual users and actual process. And what we did next with the free flow approach and with static signage, we developed some dynamic signage where we went to the factory itself. We took one of the corners of their development suites and we simulated the work cell. And participants were performing with Iveta pick and place tasks. So in the tubes, in some of the tubes, there are bolts, and participants need to push a robot towards the right tube. Then robot goes, picks the bolt, and presents to the user. And while users were performing the task, the signage were indicating that everything is going right. So, or something, the pressure is applied too strong towards robot, or participants pushing the robot too quickly. And when that is decreased, once again, it's indicating that it's going right. And so one condition was experimental with this kind of signage. Another condition was when participants did not get the feedback. So we noticed that experimental group participants were on average faster completing the task, although accuracy between control and experimental conditions did not differ. And in the control group, participants' average response time predicted 27% of self-efficacy change. So what it means that experimental group participants, they had their self-efficacy or confidence that they are performing correctly well on the task more or less consistent irrespective of their performance or their performance speed. But control group participants who did not get that visual feedback, their self-evaluation of their own performance depended very much on the on how quickly they were performing. So the longer they took to complete the task, the lower was self-efficacy. And this relates very much to the resilience and psychological well-being. And if people feel confident in their task, their downtime is less. So it's less likely to experience burnout or stress or anxiety, and people are feeling more confident and more positive while working with the robot and while completing the task, which results in faster completion times also, increased efficiency, and just happier workforce. So just to conclude everything. So what did we find? How graph communication with the user can help manufacturing and operators. So acceptance and trust in robots come with knowing the aim of the coming changes. So when participants, operators are involved in designing process, they know that something is happening and they know what is happening and what is going to change. Also in-depth knowledge about process and dangers involved. So they know that how the new process is going to look like, also how to know when things will go wrong and how to fix them. And employees being involved in the decision-making and planning of the process, just in general feeling more empowered and contributing to the process. It's not that decisions are put on them, but they are actively participating in those decisions being made. And information regarding robot operation can result in efficient task completion. So both in terms of completion time and accuracy, also decrease negative attitudes towards robots and anxiety, and stable self-efficacy or confidence and positive emotions, so increase the psychological well-being and resilience. And in general, take-home message is that involving users in early stage of development can increase acceptance and ownership of the process and reduce the anxiety surrounding the new technology. And just the final message, what I like to present in this kind of presentations is we asked participants during the last workshop to draw, to design a t-shirt and giving the task that what would you say about robots to people who did not attend the workshop. And you can see there are people who draw just generic robot, but more interesting ones when they start communicating that robots can be useful or they can increase safety, ease, quality, productivity. Robots are the future. And my favorite is the robots are coming. So they are definitely coming. Just come and ask me for more information, but we need to be prepared for that. And all this work was done partially in various projects in Sheffield Robotics and also on the Sherlock project, which still carries on. And maybe this year, there will be continuations of the variety of the work done here. And next time you will hear a bit more. So thank you very much.
Thanks so much, Iveta. So much packed into your presentation. It's really, really interesting. Do we have any questions from anyone, please, for Iveta?
I don't really have a question. Thank you, Iveta. It was a very, very nice presentation. I just want to say that I particularly appreciated your emphasis on the necessity of testing in field. And I think this is really important. We can perform all these simulations in labs, but it's really not the same. It has to be tested in field with real users, and that's the only way to go. And I just want to say that. Thank you for this. Thank you.
Completely agree, Isabel. It's just, although it produces similar results, it gives so much more depth and understanding what is actually happening. So field studies are the only way forward and definitely needs to be included there.
Yeah, definitely. Yes, thank you.
But also, may I add, with a scientific approach, which is what Iveta's got through her work, there's a lot in the literature of human analysis, but Iveta's applying a very experimental and field work, very scientific approach, so results are reliable. So, do we have any other questions?
Yes, I would have a question.
Yes, please, Mario.
Thank you, Sarah. Thanks, Iveta, for a nice talk. And I was wondering whether you or how you plan to transfer the results you're gaining or you gained from these experience and from the experiments, how you transfer the results to engineers, in which form you plan to communicate the results to engineers who are supposed to then incorporate these results into their new designs, into developing a software that implements the requirements that you can elicit from from the results you have?
So I think the best example is ongoing Sherlock project, and so the signage with Avatar, because we went with engineers and designers. We developed that signage. We tested with users, but also general public. We got some comments explaining what people like, what they don't like, what was clear, what was not clear. And that resulted in the next iteration in actually experimental study where we narrowed down, improved the signage, once again tested that. We got quality feedback, we got quantitative feedback from the users, and the next stage is actually adjusting once again, improving the process, taking that to the factory. The factory, so our industrial partner who's actually planning to introduce that and testing on their workforce, getting feedback from their workforce, improving, and then getting that final product which we can give to the company. But in addition to that direct line of work, it's also public engagement, talking through conferences, and just in general engaging with the designers, with the engineers and general public, and communicating how it is important, how the users are perceiving robotics, how they want to interact with it, and how we can make sure that that future is as positive as possible and benefiting not only the technology or companies, but every single human being. So yeah,
Thank you.
it's general by communicating.
Mario, are you perhaps suggesting that Iveta needs to write a handbook for engineers?
There are no clear suggestions, but I can imagine that this could be very useful. Yeah,
Okay.
absolutely.
Thank you.
Not to give you any more work, Iveta, but I just thought it was a good idea. Do we have some spare time before break? Would anyone like to ask another question of Iveta?
I had a question.
Oh, yes, please.
There were some very nice user studies that you presented here. Do you think user studies is the kind of only feasible way to do this, or are there some general principles that can be kind of applied to new applications regarding the design of the displays, or what information is needed for the operator?
So the work presented here came from two very, well, I can't say different, but they were done in different laboratories. One was 3-4 years ago, another is very recent. And although we have the time difference, different labs, different participants, we still get some similar findings. So there are universal needs that users need, but there's also some specific needs which depends on the process. So my suggestion is, yes, read the literature, apply universal needs, apply what has been found before, but also you can't skip the step where you're interacting with the user. You still need to involve them in the process, even just to help them to feel more empowered and engage with the new processes and feel that, yes, the decisions are not just dropped on me, but I'm part of the decision. This is also my thing. And also, you never know, you might find maybe there is, with that particular process you're designing, maybe it has something very specific what has not been investigated before. And by interacting with the users, you will find that out. So yeah, you need to do everything. Yeah, I know it's not easy and it requires time, but the results so far suggest that incorporating everything, so findings in the literature, universal principles, and also incorporating users, that results in the highest uptake of new technology, and that users are enjoying that, and the company gets the biggest benefit.
That's wonderful. Thank you, Iveta.